Hello viewers, welcome to my channel KK Concepts of Electrical Engineering. Faraday's law of electromagnetic induction. Whenever the flux linkage of a coil changes, an EMF is induced in the coil. The magnitude of induced EMF is given by Faraday's law and the direction is given by Lenz's law. Let us see what is Faraday's law. Faraday's law states that the electromagnetically induced EMF is equal to the time rate of change of flux linkage of the coil. EMF equals to time rate of change of flux linkage of the coil. Let N is the number of turns in the coil. Phi is the total flux. Now flux linkage is total flux multiplied by the number of turns in Weber per turn. Time rate of change of flux linkage dt of total flux linkage into pi. According to the Faraday's law, induced EMF small e equals to n d phi by dt volts. Lenz's law. Lenz's law states that the direction of electromagnetically induced EMF is such as opposes the very cause which produced it. The direction is opposing to the cause, that is EMF, then E equals to minus n d phi by dt. This is n volts again. Now consider open loop coil. So n equals to 1 in this. I'm having a magnet. Now when magnet is moved towards the coil, the flux density B is going to increase, and when magnet is moved away from the coil, the flux density B is going to reduce. In both the cases, flux linking the loop changes and an EMF is induced in the loop that is measured with the help of voltmeter. In electrostatics, we know induced EMF E is given by closed integral of E dot dl. We know flux is given by surface integral of B dot ds. From Faraday's law, we know that EMF E equals to minus d n phi divided by dt, but this is a closed loop where n is equals to 1. For our case, that E equals to minus d phi by dt. Let this be A, B and C. Substitute the value of phi in this, then you are going to get E equals to minus d by dt of closed surface B dot ds is our phi. Let this be equation number 1. If the coil is stationary, then equation number 1 is going to modify it like E equals to minus integral surface at dB dot ds by dt. Volts. This equation is known as transformer induction equation. From a and 1, we can write E equals to closed surface integral E dot dl, which is equals to minus integral surface integral dB by dt of ds, which is also in volts. And this relation is known as Maxwell's equation derived from Faraday's law. And this is also known as integral form of Maxwell's equation. Try to derive a point form or differential form. Then from Stokes theorem, closed line integral of E dot dl equals to surface integral of del cross E dot ds. Now, from these two equations, let this be 4 and this is 5, we can write that surface integral of del cross E dot ds equals to minus surface integral of dB by dt dot ds. The surface integral on both sides may be taken over identical surface, then we can write del cross E equals to minus dB by dt. This relation is known as point or differential form of Maxwell's equation. If the flux density is not time changing, that is dB by dt equals to 0, then equation number 4, E dot dl equals to 0. And this point form is going to change like del cross E equals to 0. These two relations of electrostatics. If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.